Greetings, friends of chemistry. We are doing the On Your Own 13.1 from Module 13. Martin, will you please read On Your Own 13.1?
Write balanced chemical equations for each of the following processes, being sure to include energy as either a reactant or a product. The formation of H2SO4, which has a delta H of negative 814 kilojoules. That's A. B. The decomposition.
Let's do this first,
Okay.
and then we'll, because I won't have room to write those all here and then do problem and stuff. All right. So this is a formation reaction that they want us to write.
Yes.
So tell me what that means. What are we going to do? We're going to take or look at this, which is the
reactant.
What's the end result, right?
Result,
This is is this atoms of individual elements, or is this
a molecule?
Yeah, this is a molecular compound, right?
Yes.
So we're going to take the individual elements. What are they?
Hydrogen, sulfur, and oxygen.
And we're going to put them together and make H2SO4, right? So
yes.
We'll write about, and we're going to include the energy. So here we have a negative delta H. What does delta H stand for? How should we read delta H? Where do we find that? Find the definition on page 419. It says it's the change
that accompanies
in enthalpy. The energy change that accompanies a chemical reaction. So what does the negative
there's no
enthalpy here tell us?
That it's an endothermic reaction.
Okay, so that's true.
Oh no, it's exothermic.
Exothermic reaction. So you can think of the reaction as producing that energy, right? So an endothermic with a positive delta H, right? An enthalpy that's positive, or a change in enthalpy. Will be a reactant, okay? So here we go with the H2SO4. So how many hydrogen are we going to have in H2SO4? How?
2.
And how do we find hydrogen in nature? They're either ions or they're going to be H2, right?
Yeah.
Which is a diatomic, homonuclear diatomic, right? Yes. So we're going to look at it as H2.
Yeah.
Because we're not told not to. Okay, so H2 plus what?
Plus S.
Plus S, sulfur. Plus what?
2O.
Right, because oxygen is also a homonuclear diatomic, so we're going to have 2 of those in 4. Right?
Yeah.
Now, because we have a negative enthalpy, right?
Yields H2SO4 plus 814.
Since we have a negative enthalpy, it's exothermic, and we're going to think of the delta H, the enthalpy, as a product, right?
Yeah.
So we write that number. Yields H2SO4 plus 814
kilojoules.
Okay, now let's check with the back of the book. The back of the module and make sure we did that right. H2. Beautiful. Okay, so now we're looking at letter B on page 421. All right, letter B says what?
The decomposition of K3PO4, which has a delta T of 2030 kilojoules.
I'm sorry, delta H.
Delta
yeah.
H, right.
An enthalpy, or a change in enthalpy of what?
2030 kilojoules.
So remember, the delta H, sure, that's what you want to write down. But think of it as enthalpy or change in enthalpy.
So would that be?
Okay. So when we have a positive,
then it's endothermic.
Then we're going to think of it as a reactant,
Yes.
right? Okay, so we're going, this is decomposing. So over here is where I have this, okay? Instead of in this product, in this equation where it was product, here it's over here, okay? Plus is going to yield what? So how will this decompose? Oxygen is a homonuclear diatomic, but are these other? What is K? Do you know?
No.
K is potassium,
Okay.
and P is phosphorus.
Mm.
So it's potassium phosphate, right? That PO4?
Yes.
Okay. So it's going to decompose into potassium and phosphate. And again, the homonuclear diatomic oxygen, right?
Yes.
Do I have my numbers right? Are we balanced? Are you feeling your zen?
My pi is strong.
So true.
I sense a disturbance in the force. How about you?
You ready with letter C?
Yes. The reaction between H2CO3 and KOH, which releases 21 kilopascals. But they said that they wrote the unit kcals, 21 kcals. Pretty sure that's kilopascals. It's supposed to be different.
No. Okay.
Oh.
So how do we deal with this? What kind of a reaction is this? This isn't a, excuse me, this is not a decomposition or a formation reaction. What is this? This is one of those.
We've done reactions before.
Acid plus base yields what?
Water and
Salt.
Salt.
Plus water.
Right.
Some kind of salt plus water. So which is my base? Obviously this with the hydroxide in it, and this is my acid,
Yeah.
right? So this will be part of the water, right?
Yes.
And this will be part of the water. So what will my salt be? It's going to be of what? Potassium.
Potassium carbonate.
Carbonate. Excellent. All right. So H2CO3. And where does my energy go in this one?
On the reacting side. Reactant end result side.
Now,
Do we have to do it in joules? I think it specifies. Okay.
I don't believe that we need to put the energy into a different form. The energy here is positive.
Yes.
So it's endothermic. In an endothermic reaction, we think of it as a reactant. Just a minute, hold on. Oh, it releases. Stop. It doesn't tell us it's positive or negative. We have to figure that out. If it releases 21 kilocalories, is it positive or negative? What kind of reaction is
negative.
it? Is it
it's
exothermic? Yeah, so it's releasing. So it's a negative. So it's actually a product. All right. So we have H2CO3 plus KOH yields. What is the charge of this and the charge of this? This is plus, and this is 2 negative, right?
Yeah.
So we need 2 of these. So we're going to have to adjust our. So we have 2 K, 2 CO3 plus
H2O.
2 H2O plus
21
21
kilocalories.
kilocalories. Right. So, and that's it for 13.1. Any questions, Merton?
No, but a statement. Bippity boppity boo.
Thanks, Tinkerbell.